Hi everyone. So today we're going to go over rocks. Each of you will have the opportunity to check out a box of rocks, and I'm just going to go over them with you really quickly today. The lab handout is on D2L, as well as some photographs of these rocks. So if for some reason you decide you don't want to check out a box of rocks, there will be photographs up on D2L. Now you won't have to identify these rocks. Typically I would do that. I would pass around some rocks in class and have you identify them, but I'm not going to do that this semester. There is a quiz on D2L, so after you're done going through the laboratory and looking at all the rocks, go and answer the questions that are on the D2L quiz for Lab 1. All right, so what I'm going to do, I'm not going to read the lab aloud. I think that you guys are all capable of doing that. There are some basic definitions of different types of rock, and that would be igneous, sedimentary, and metamorphic rock. So I do want you to know what those are. I would say that I'm going to add to the definition that we had in class with regards to igneous rock, where that's rocks that are formed from molten materials. And in your lab handout, I've kind of discussed that there is a difference in types of igneous rock, whether they're basic or whether they're acidic. And a basic igneous rock will have a really high percentage of iron, calcium, magnesium, and sodium, and contain less than 50% quartz. And an acidic rock would contain greater than 65% quartz. So kind of be aware of that and be kind of familiar with it. There is a disclaimer in the laboratory as well. I mean, obviously this is not a geology course, but what I want you to know basically is the minerals present in the rocks that we're looking at in this in these sampling, this box of samples. So think about that as you're looking through them, because as these rocks weather, they're going to release those minerals into the soil, and they may have a function in soil. So remember, a rock is just a considerable mass of one or more minerals, and let's go through the igneous rocks. So the very first one I have here, and if you were to compare the different boxes that I have in class, they're all very similar, but there are some that vary a little bit. Since you don't have to memorize these rocks, that's not going to be a big deal for you. The very first rock that we have is granite. So we're all familiar with granite. We're here in St. Cloud. It's the Granite City. And so when we see granite, it's pretty common around these parts. This one is a pretty dull piece of granite compared to maybe some of the other types of granite that you've seen in your life. There are all kinds of granite countertops, and you've probably seen them, all different colors, different patterns within them. So you know that this sample in this box doesn't represent all granite. All right, so what kind of minerals are in granite? And that's going to be what we're most interested in. So we might see some orthoclase in there, some plagioclase, some quartz, some mica, and some hornblende in there. It is considered to be acidic because there's a high content of silicon dioxide in it, or quartz. All right, just remember, we can find granite in all different types of colors and patterns. All right, the next one in our box is obsidian. This is a pretty cool piece here. It actually looks like glass, and that's what it's called. It's called volcanic glass. And you might find this in areas where there was volcanic activity at some point. I actually found a really nice piece of obsidian in Alabama once, where we don't have volcanic activity. This too is acidic, and that means that it has greater than 65% quartz. It is very similar with regards to its composition as granite is, but it cooled very quickly. And so that eliminated some of the crystalline formations that we saw when we had granite. So you get this glass look rather than the crystals. So one really common feature is these kind of curved features on the sides. Obsidian can actually be used as a cutting tool. So there are even, you might even find maybe some arrowheads, spearheads that are obsidian. And there are actually some scalpels made with obsidian because they can be extremely sharp cutting tools. The sharper the cutting tool, the less damage to the skin, so surgeons can use it for surgery. The next one we're going to look at is a really interesting one. So if you take that one out of the box, the first thing that you'll notice is that it's very light compared to the other ones that you've looked at so far. It's very light. In fact, you might actually be able to get this to float in water. I have seen pictures of pumice floating in the ocean, and when vessels sail through it, it's really kind of eerie to see all these rocks floating. The sponge-like holes that you see in it are actually from the volcanic gases that were released while it cooled, and that kind of hollowed it out, and that makes it very, very light. You might be familiar with pumice soap. Basically, it's a soap material that has ground up pumice in it. It kind of gives you an abrasion effect when you're cleaning your hands, particularly if they're really greasy. Yeah, so you might be able to use it for something like that. The next one is basalt. Now this piece right here that I have from this box really obviously shows a lot of the pores, those holes. We call that a vesicular appearance, and those holes are where gases escaped while it was cooling. The other thing that I would say about this in comparison to the pumice that we just handled is that it's very heavy. And one of the reasons why is that basalt contains iron. It's usually pretty rich in iron, and you can kind of feel that weight in it. It is a basic rock, so in comparison to granite and obsidian that we had before, this is basic, which means it has less than 50% silicon dioxide or quartz in it. But it also contains things like biotite and hornblende. Our next one is porphyry. And porphyry actually has the exact same composition as basalt. So they're kind of like cousins. They have the same composition, they don't look the same. This one cooled very rapidly and we had gases escape. And this one cooled much more slowly and we got crystals that formed because of that. So same type of composition as you would find in basalt, but they look very, very different, and that has to do with how they cooled. Our next one is actually metamorphic rocks. So we're going to start looking at some metamorphic rocks. I don't like how the box is actually ordered. I would have liked to have looked at the sedimentary rocks first, but I'm just going to keep it in the same order as they are in the boxes. So this one right here, number 6, is called gneiss or gneiss, and it's a metamorphic form of granite. So if I go back and find my granite piece here, these two would have the same composition. Granite and gneiss would have the same composition, but this one went under some metamorphic process over time, and so it's a little bit tougher. Now, one of the cool things, and I don't know if you can see it really well on the camera here, is that it has these dark bands, and that's one of the things that will really point out gneiss in comparison to granite. So here in St. Cloud at the wastewater treatment plant, they actually have a building that's made out of granite, granite bricks actually. And every so often you'll actually see a brick that is actually gneiss instead of granite. Same composition, they probably found it in the same spot, but this is a metamorphic version of granite. So everything that would be released from granite will be released from gneiss. Number 7 is schist. Now this sample that you have in your box really doesn't do justice to how schist can actually look. Schist can be a very nice and beautiful rock. It sometimes actually has a glitter appearance to it, and that has to do with the mica that is in the rock itself. So next week we'll be talking about minerals, and mica is a type of mineral. It does really have kind of a glitter effect. I can remember walking in some creeks in Alabama and actually seeing weathered schist in the creek, and it would sparkle almost like fish scales in the water. because it just breaks down into the micro minerals. It can come in lots of different colors too, and that's probably true of a lot of the rocks that we have in our sample box here, is that the ones that you see in this class aren't necessarily the same colors you'll always see everywhere else in nature. All right, so that's kind of an important one when it comes to potassium-rich soils. This will contribute a lot of potassium from the mica that's in it. All right, our next rock is slate. You might be familiar with slate. You may have heard of slate before. This is a metamorphic version of shale. Now, we have not talked about shale yet because shale is a sedimentary rock, but we do have a sample of that in our box. And slate is just a metamorphic version of that. Usually when they're metamorphic versions of something else, they're tougher. They're harder to break down. They're harder to weather. And so this metamorphic version of shale that's now slate might be more difficult to weather than shale itself. And it's made of sedimentary rock that was basically just layers and layers of mud that was compressed together, turned into rock, and this then metamorphosized under heat and pressure. The next metamorphic rock we're going to talk about is number 9, and that is marble. Again, almost like granite, we use marble a lot in building materials, and you'll see lots of different type of marble. Some have nice gray streaks in it. This one doesn't really have that in it. But marble is a metamorphic version of limestone. Again, we haven't looked at limestone yet. It's a sedimentary rock, but we do have a sample in our box. And so if this were to decompose, it would decompose the same way that limestone would, and it would release calcium carbonate into the soil. So calcium would be the thing that would be released. Kind of an interesting thing here with this is that because it's made of calcium carbonate, it is vulnerable to acidic environments, so acid rain. So marble and limestone will actually dissolve when there is acid rain. Now, this won't dissolve nearly as easily as limestone because this is a metamorphic version of it, but it will kind of break down over time. So if you've ever been to Europe where acid rain has been a particularly heavy problem, and they have these old ancient marble statues, oftentimes they look deformed because they've been hit with so much acid rain over the centuries that they've begun to decompose and melt away. All right, the next one we have is quartzite. This is not a rock that's particularly attractive. It is a metamorphic version of sandstone. Now, we haven't talked about sandstone either, except we did talk about it a little bit in class. We do have a sample in the box that looks very different than our quartzite here, and that's not unusual. We're going to find all different kinds of color of quartzite, all different kinds of color of sandstone. But this is a metamorphic version of sandstone. It does not feel sandy like we would think sandstone would. And so it wouldn't break down nearly as easily as sandstone. So this is going to contain quite a bit of quartz in it. Our next one is the sedimentary rocks that are in here. Unfortunately, I don't think I have a great sample of number 11 in my box here, but this is conglomerate. And oftentimes it looks like concrete. It looks like really poorly poured concrete. Sometimes you see very large pebbles in it. Maybe your box contains one of those. Basically, it's very large sediment, sand, pebbles, and stones that have been cemented together with some dissolved minerals. And so we'd find this in an area where sedimentation has occurred. All right, so this one isn't, I don't see any really big pieces in here, and some of the samples do, but it does just look like concrete. Our next one, number 12, is gypsum, and we're actually going to see this in the box of minerals next week. Gypsum in our class is going to be considered both a rock and a mineral. It's made of calcium sulfate. It can be used as a fertilizing material. It can also be used as a liming material. Now, we haven't talked about what that means, but when we add lime to soil, it actually brings up the pH of soil. And this can be used as a liming material because it contains calcium. Sometimes it's used as a fertilizer material because it also provides calcium as well as sulfur, and that can be important for some plants. This can be found in lots of different colors as well. So just because it's white does not mean that all gypsum in the world is white. Our next one is shale, and we've already talked about shale a little bit because we have slate in our box, and slate is a metamorphic version of shale. In this case right here, I think the camera picks it up pretty decently. We can actually see the layers of clay. So really fine particles of clay. We haven't talked a lot about particle size, but clay is really small particle size material. Sandstone would be very large materials cemented together. And sometimes we use this for building materials. Both slate and shale can be used for building materials, roofing materials, flooring materials, that type of stuff. Our next one is limestone. And this one does look quite a bit different than the marble that we have in our box. But limestone is a sedimentary rock. It's made out of calcium carbonate. If it's dolomitic limestone, it's made out of calcium and magnesium carbonate. And if we find a metamorphic version of this, it will be marble. Now this is much more sensitive to acid. So marble would hold up a little bit better against acid rain, whereas this might dissolve pretty easily. In fact, if I had some concentrated hydrochloric acid with me and I dropped just a drop or two on here, it would effervesce or fizz. And what's happening is that you have this reaction that's going on, this acid-base reaction, and calcium salts are going to be released, and carbon dioxide is actually going to be released. So when you see the bubbles, that's actually carbon dioxide bubbling off of the rock as a reaction to the acid. And then the last one in our box is sandstone. And this doesn't look anything like the quartzite that we had, but you can actually feel the texture on this one. Where quartzite actually felt pretty smooth, this one actually kind of feels like sandpaper. And that's because it is sedimentary rock made from sand. And so when I showed those pictures from Arizona and we saw those beautiful wind-blown carved stones, it's because sand was dislodged off of these rocks, and then that sand became the sediment load in the wind, and that sand blasted those rocks, releasing more sand into those really beautiful shapes that we saw. All right, so that's basically it. So you have a quiz. You can answer all the questions there on the quiz. It's not timed, so you can take as much time as you want to flip back through the lab materials and kind of answer those. You would be responsible for those labs for future tests. So at some point you might want to look back onto your laboratory. I'll be glad to answer any questions that you have. In Wednesday's class, I'm gonna let you sign out a box of rocks. I want you to take good care of them. If you're gonna check one out, I want it back in the same condition that you received it. And then on Monday, I'll pick them up. So the goal here is that Friday, we will not meet as a class. I'll have this all up as a virtual activity for you to do, but I'll be available for any questions that you might have. So you can email me, you can drop in during office hours if you have some problems or issues. All right, I'll see you in class.